Today we're going to be talking about arithmetic series. The difference between a sequence and a series is, as we saw in the last lesson, a sequence is just a list of numbers that have a very specific pattern. A series is the sum of those numbers in a sequence. So take a look at this example. If we look at this Lego pyramid, and we want to know not how many blocks are in a certain row, but instead how many blocks would it take to make a pyramid with 8 rows, we could go ahead and list it out. We could go ahead and use the formula from the last lesson to figure out how many blocks are in each row, and then we can use the formula from the last lesson. Or we can use one of these two formulas. So this is how to find the sum of numbers that are in a sequence, either this formula or this formula. Most of the time we're going to be using the first formula, but every once in a while we'll use the second one, depending on the information that's given to us. And again, you do not have to memorize these formulas. These will be given to you, but you do have to know how to use them. And so just to look real quick, n stands for whatever, however many terms are in the sequence that we're finding the sum of. A sub 1 is your first term, a sub n is your last term, and d is your common difference. So let's take a look at some examples. So we want to find the sum of this particular sequence. We want to find the sum of the terms in this sequence. So we have all of these, we have all of the information here, and we're going to go ahead and use the first formula from the other page. So this is S sub n. I'm just going to write the formula down here. And we're just going to substitute in these values. So S sub 18, again, this represents the sum of the first 18 terms of this sequence. So we're going to have 18 over 2 times 7 plus, and then a sub n, or in this case, a sub 18, which is 119. And so we have 9 times 126, which is 1,134. And so again, that represents the sum of all of the numbers in that particular sequence. In this example, we're given some different pieces of information. So in this one, we would have to use the second formula. So here is the second formula again. And we can go ahead and use the information. So we want to find the sum of the first 13 terms for this sequence. So S sub 13 is equal to 13 over 2. And this is going to be 2 times our first term, which is 5, plus n is 13 minus 1, and that's times 0.5, which is our common difference. So we have 13 halves times 10 plus 6, and we end up with 104. So this represents the series. So this is the sum of the sequence, and we refer to it as a series. So that's what that 104 represents. So this is just kind of doing the same type of example, but just written in a different way. So we have to find some information here. One thing that we can find is the common difference. So the difference here would be 3. So you're just going to take the second term, subtract the first term, and we can see that that's the common difference for each one. So, oops. So the common difference is 3. And we have to find the sum of this. We don't know how many terms there are, and so we need to figure out that first. And so we're going to go ahead and use a formula from the other day. So 25 is our last term. And we're going to take the first term plus the difference times however many terms there are minus 1. So that was the formula from the other day. And we're just going to go ahead and solve for n. All right, I'm going to go ahead and distribute or divide by both sides by 3. And so sometimes you have to figure out what the information is first before you can use the formula. So this is 8, add 1 both sides. So n is 9. Now we can go ahead and use the other formula. So s sub 9 is equal to 9 over 2. And hopefully you have that formula in front of you. You can just follow along. First term plus the last term. And we get 117. So this is the sum of this sequence. So I'm going to introduce you to some new notation. I don't think you've seen this before. This is referred to as sigma notation. And let me just get all this in here. And so this symbol right here, that's the sigma notation. And what it represents is this expression. What we're going to do is we're going to substitute in the values for n from when n equals 1 to n equals 5, and then we're going to add all of the terms together. And so I'm going to show you, I kind of want to get this on the same, I'm just going to scoot this down a little bit. I'm going to show you what this looks like. So the way you evaluate this sigma notation is we're going to take this expression, and first we're going to substitute in 1 for n, and then we're going to just keep adding all of the terms together. Then we're going to substitute 2 in for n, and so on until we get to 5. So this is one way to evaluate the sigma notation. Okay, so once we've gotten to the last term, we can go ahead and evaluate this. So this is going to be 2 plus 5 plus 8 plus 11 plus 14. And when we add all of those up together, we get 40. So that's one way to evaluate that notation. I'm going to show you another example. And for this one, I'm going to use the formula for the series. So the first, we do need to figure out a few things. We do need to figure out a sub 1, our first term. And so for that, I would plug in 1 in for n, and I would get 2 times 1, which is 2. Let's write it out here. So this is going to be 2 plus 2, which is 4. And then our last term, a sub n, or a sub 4 in this case, I would go ahead and substitute 4n, and I would get 10. And then there are 4 terms total. So if I substituted 1, 2, 3, and 4, that's going to give me four terms altogether. So s sub 4 is going to be equal to total number of terms divided by 2 times our first term plus our last term. So this is a little more straightforward than writing every single term out. And so we get 2 times 14, which is 28. So you get the same thing either way. I just want to show you one more thing here. Just be careful you pay attention to the very first term. Sometimes you're not going to start with 1. Sometimes you'll start, in this example, you would start with 3. So go ahead and try to find the sum of this expression here from when n equals 3 to n equals 6. You can use either way that I just talked about. All right, and we will continue this in class. See you then.